It's for the Marit, it's for the shock effect, right? Wow. Okay. Mic's already on. I have 3 more minutes, no, before I start? Or do I start now? Let's go. You guys are just like, yeah, whatever. Whatever Belgian guy, just do whatever you want, right? Fine, I guess we'll start. So, good afternoon, everyone. How are you doing? Good? Still excitement on a Friday afternoon. I love to see that. See you even yelling. Good. So I hope you enjoyed the conference. I'm not quite sure what I will tell my wife once I get back to Belgium, because I learned a couple of things today. I learned about llama. I learned about goose. I learned about duck. So I'm probably going to have to tell my wife that I went to some sort of petting zoo today. But there's one animal that I absolutely love that was missing today, and that's a cat. Any of you are cat lovers? Cat lovers? Great. So I actually tried to bring my cat here, but he was not cooperating this morning. He did not want to join me to this conference. And I understand. I mean, he likes his comfy little space at home. And I love cats. And what I love about cats is that they have become the de facto kings and queens of feel-good internet content. Whenever you want to feel good, you just you look at some cat pictures and cat videos and you feel better. And what I like about current times is we have Gen AI, so we can make more cat content. For example, a cat sitting on a crocodile while playing a banjo, boom, there you have it. A cat in a tiny top hat hosting a stand-up show for a crowd of impressed goldfish, boom. Although, to be fair, this one does not look impressed. And you know, I wasn't able to bring my cat, but I did try out Sora today. So if you don't know, Sora is a way by OpenAI to generate not just images, because these are all ChatGPT, DALL-E images, but video. And it looks like this. So this could have been today if my cat would have been cooperative. But it was not. So, just to say, Gen AI is awesome. And I think it's very cool technology that we should use and abuse to create more cat content, but also to help us with other things in our lives that make it a bit easier. You have this mail, and you want to send it politically correct, but you're actually very angry. You type a very angry mail. You ask, please make it politically correct. And Gen AI will take care of that for you. So there's a bunch of good things I can say about Gen AI. Whenever I read about Gen AI online, it is spouted as, this is going to be the solution for absolutely everything. We are done as human beings in life. It's going to solve everything. And then I think, yeah, maybe it isn't the solution for everything. The problem is when I try to, you have these people that are super hyped up about Gen AI. And when I say, or is it, when I doubt our new overlords, I get a lot of buts. Single T. So a lot of buts. And it is, yeah, but it will get better with RAG. But it will get better with fine-tuning. But it will only get better. But, and then the next idea that comes like in a couple of weeks, right? But what I want to talk about in this talk today is talk about something that LLMs can't do. Because I think too many other speakers, well, it's a good thing that a lot of other speakers are speaking about this, but I think it's important to still realize that these tools can't solve everything. And that's what I want to talk to you about today. One thing LLMs can't, and that's something I'm very passionate about, is solving planning problems. And these planning problems are actually everywhere. For example, when you have couriers that actually need to deliver packages to different locations, someone needs to plan that. If you have 2,000 packages and 20 vehicles, what is the best combination of packages, vehicles, and routes? Someone has to calculate that. Airports are full of scheduling and planning problems. Airlines need to be scheduled. When you go to the desk to check in, did you notice that that's the same people that also check you in at the airplane? That also needs to be scheduled. Maintenance of these things needs to be scheduled. The world is really full of these problems. And recently I was talking to my neighbor who actually does the scheduling for nurses in a hospital. You know, 50 nurses and they each need to be assigned and everything needs to be taken into account like holidays and skill levels and so on. And my neighbor actually asked like, yeah, but these Gen AI things, can it solve my planning problem? And I thought, this is the thing we see, right? People, whatever problem we're talking about, people think that with LLMs it's going to be a walk in the park. Every problem on the planet. So we put it to the test. We tried it. Like, how does it solve these problems that are everywhere around us, all these planning problems? And the results were very disappointing. I had a few examples where one person got assigned all the shifts. I remember in my example data, his name was Carl. I hope there's no Carls here. I hope not everyone is assigned to one shift. Or just random weird stuff, you know? But instead of just going, yeah, LLMs are bad at this, it's why are they bad at this specific problem? Why are they bad at solving these planning problems? And we actually identified 2 potential reasons. Challenge 1, context window size. So in case you don't know, the context window is basically how much things the LLMs can process in one go. Like it's like a random access memory, like a RAM memory, but then for an LLM. Just simply put, I know I'm taking some shortcuts here, but so these things, these context windows, are limited by an amount of tokens. You've probably heard this if you've been involved with LLMs. Oh, it costs this many tokens. So the data you need to schedule 10 employees is about 3,400 tokens. So that's all the data, being the name, last name, when they are available, what skills they have, and so on. If we scale it out to 100 employees, we're already at 34,000 tokens. And 100 employees is like an average use case that I'm seeing out in the wild. If you go to 1,000 employees, which sometimes happens, you're at 340K tokens. And this is just scheduling those employees for 1 week. Now, I don't know about you, but if you are living by a schedule, you don't want it to be scheduled 1 week, you want it to be scheduled a month so you can plan like personal life and other stuff, right? So if we take the middle one and we extrapolate it to times 3, so let's say we need about 100K tokens to schedule something. So what's the context window for current LLMs? Well, past generation, it was 8K. I'm asking for 100K for like a basic case. So that wasn't working out. But more and more recently, you can see that context windows are being expanded. And currently, we're at 120K tokens to like 2 million tokens. So probably this context window problem that we're feeling with these scheduling things is temporary. Because all these context windows are just increasing and increasing. And that's what you hear a lot of marketing people say as well. We're racing to the biggest context window, but there's a big but again, still with a single T. Still with a single T. No, exception. So there's this GitHub repo, and I'll show you. Yes. So does anyone know this repository, NVIDIA Ruler? It's actually a benchmarking tool that the guys from NVIDIA made, so there might be a bit of bias because it's a company that makes LLMs, you know. But what they actually did was they compared the context length, and they checked, like, if something reports, I'm going to make it a bit bigger for you. So if an LLM says that it has a context window of 1 million, can it actually do sensible things if you fill it with 1 million tokens? Because a lot of these things are saying, I have a context window of 500K, but they become useless as soon as you put like 64K in there. And that's what this benchmark says. And I actually like this one a lot. Where's the one? Here, GLM4. They say that they have a context window of 1 million, but they kind of become useless after 64K. So I'm not fully convinced that the context window problem will resolve itself in the end. So context windows might be a problem. Problem will probably get better. But some nuance, right? It's not just about the biggest context window. But that's not the real big problem that I think these planning problems have when it comes to LLMs. The second one is the problem size, just the sheer amount of possibilities. Now let me do a short pop quiz. Imagine you have 10 employees. 10 employees with different skills, preferences, and so on. You're going to schedule them for 7 days. There are 3 shifts per day, so morning, afternoon, evening. And on average, you need 3 employees per shift. How many different combinations can we make? For 10 employees and... Anyone? I see people calculating on their phone, so you're disqualified. Well, this might surprise you, but even a simple problem, 10 employees for a week, has 10 to the 63 power combinations. Now, that's a format we don't see often, so I also did this. So it gives a bit of a better idea how big the problem space is. So these are all the different combinations you can make with 10 employees. So this is a very difficult problem to solve efficiently. And in case you don't know, but I think most of you do by now, LLMs basically take the statistically most likely next token. When you have a problem space that's that large, statistically most probable next token isn't going to do much for you. So now there's this new thing, right? There's these reasoning models that can reason and can iterate on themselves. So how are they doing then? To be fair, sometimes they succeed on very small data sets, but they think like humans. You can actually see it in the prompt output. It thinks like, oh, I have Anna and Carl, and I need to schedule them this and so. But you don't want to think like humans necessarily when you're talking about this larger scale. Human logic doesn't really work that well, like textual doesn't work that well. Actually, an example here. So this is part of the reasoning prompt. So you ask it to ChatGPT, and it will start reasoning for 3.5 minutes. And then it will come with somewhat of a decent solution. But you can see it's actually thinking like a human. And that makes it really complex, because sometimes the best solutions are actually something completely different or like a different approach. So this just doesn't work for this kind of problems. So in short, why do LLMs fail here? It's the context window and the problem size. Those are the 2 big problems here. So LLMs can't make these schedules, even though the scheduling problems are everywhere, as I showed you, like even school timetabling. The schedule of this conference is a problem to combine correctly, you know? You need to take into account speakers when they are available and so on. So these problems are everywhere. But and LLMs can't do it. But surprisingly, AI can. And we're, at least in recent times, we've gotten so stuck and made our definition of AI very narrow, where if it's not Gen AI, people don't say it's AI anymore. Right? If it can't generate cat pictures, are you really AI? But I think the solution for these planning problems and for a bunch of different problems where LLMs suffer and Gen AI suffer are actually found in the outer circles of AI, the more older forms of AI. For example, in machine learning. And machine learning it was a branch of AI where you give it enough data and it will learn from the data to process things. One of the things I love about machine learning is that it has enabled so many use cases. For example, if you have enough data, like this is sign language, you can train a machine learning model to interpret sign language just by giving it examples. I once had, I should have included the video for this, but I once trained on stage a machine learning model where I had a big plush animal and I trained it to act as a controller in a video game. You can do those things with machine learning. So machine learning is very cool. But can you use it to create these schedules, right? These planning problems? And actually, no, because there's a few problems. Because to do machine learning, it learns from patterns, but every schedule is kind of different. They don't have that much in common. Even in the same company, a schedule during the holidays will look very different than a schedule during other days. Or even a schedule made during this week at your companies will be different because you spend a few days here. So learn from data, that's where these problems really become a big problem, because often scheduling nurses is still done in Excel. there is no large amount of high-quality data available to use machine learning to train a model so that it can actually solve these problems. And machine learning is actually really good at analyzing things and making predictions and making single decisions. But in the case of a schedule, you need to make many decisions. It's like, what shift are you going to be on, and what shift are these people going to be on? Like, it's a ton of different decisions that impact each other, so you can't use machine learning just for that. So we need to zoom out even more. And now we come into the circle of artificial intelligence in the broadest sense. In here are a lot of techniques that people will now say, this is not artificial intelligence anymore, because we've gotten so used to it. And you know, artificial intelligence is always a thing you don't understand, because once you understand it, you go, that's not intelligent. You can see it now with LLMs as well. What are we saying? We probably have the most advanced AI at our hands, and we say, that's not intelligent. No, it can generate cat pictures, but it just creates the next token. So we can ruin everything like that, you know? We make it, small tangent, I think we as humans, we don't want artificial intelligence. Because once it's intelligent, then what are we as humans? So we keep moving the goalposts like, no, this is not AI. No, this is not AI. We've been doing that for about 25 years. So anyway, but in the artificial intelligence, that's where a lot of interesting things are. There is an area called mathematical optimization, and that's basically using a function, a math function, and optimizing it to make the best result. Now, there's a problem with mathematical optimization. There's not really a problem, but it's math. Some people really are a bit afraid of math, you know? Math is scary and big and difficult, and it feels, I can't do this stuff, you know? So luckily, I ran into a project a few years back, and I've been a fan since, and disclaimer, I actually got hired by the company between sending this talk in and talking here today. So I'm very hype about this. I was hype before I started working there, but now I accidentally work there because it's an open source project and they hired me. So disclaimer. Huh? So TimeFold is a way that makes planning optimization and mathematical optimization simple by taking out the math. It allows you to do optimization algorithms in domain language. It's open source. The solver part is open source. We do have some enterprise offerings around it, but you can use the solver, the really calculation part, for free. It's in Java, Kotlin, and Python at the moment, and we might expand in the future. And it's actually a framework that's existed for more than 10 years that can solve all these complex planning problems that are still everywhere in the world. So it's actually quite incredible that all of the attention now goes to generating things with Gen AI, and these kind of technologies that have been around for 10 years are not used that much. So it actually, behind the scenes, uses something called meta-heuristics. So if you want to make a big schedule, you can't brute force it, because there's too many combinations. It will take forever. So what you do is you make a quick first initial solution, and then you start moving things around. So you just, basically you take a puzzle box with all the puzzle pieces, you throw it on the floor, and then you start moving things around until the puzzle makes sense. So let me give you an example of what that looks like. Let me start the backend server. I'll make it bigger in just a second. So when I said you can define it in domain code, I'm going to show the Java example, okay? So if you look at it, we basically have two classes. I have an employee. Is this large enough to read for everyone, by the way? We have an employee, which is just a simple Java class with some extra annotations on it. And you can see it has a name, it has skills, unavailable dates, desired dates, and undesired dates. So that's things you can configure for this model. What else do we have? We want to assign these employees to shifts. So in the shift class, we have some data as well, and then we have a planning variable, which is an annotation that comes from TimeFold. And by combining these two classes together, it will actually try to fill all the employees in the shifts, but it's going to do it in a meta-heuristic style. So it's first going to create an initial solution, and it will move things around. This will become clearer when I show you a demo. So I started the demo, so it should actually work. No, that's wrong. Yes. So this is a scheduling problem. It's nurses, and you can see it's every nurse. Sorry, that's location. Let me show you. So you have a few nurses, and they have undesired dates. They have unavailable dates. And as a planner, you need to take all this into account, right? So this is a really difficult problem that many people suffer from every week, because this is done manually in a lot of companies. And with TimeFold, with the two classes I showed you and a bit more code that I won't go into too much detail with, you can actually press solve, and then it starts solving it, and it's creating this difficult schedule for you. So there's one more piece of the TimeFold code that I need to show you, and that's actually here. These are constraints, and it's basically the rules that you want the schedule to obey. So you see a required skill constraint. That means that if you have a shift that requires someone that's an emergency nurse, that the nurse you assign to that shift has the skill to do emergency procedures. You can see that there's two groups, hard constraints and soft constraints. Now, just by the terminology, hard constraints means if you break these constraints, you can't do the schedule. For example, the one shift per day, if the scheduler accidentally schedules 2 shifts for one person on one day, it's infeasible. So that's a hard constraint. The soft constraints are like the nice-to-haves. For example, if an employee has a desired day that they want to work, if you take it into account, it improves the schedule, but if you can't do it, it's not the end of the world. These hard and soft constraints, they each have a score, and let me just show you. It's all Java lambdas. The API is a bit confusing, but once you get used to it, it actually is quite okay. And for example, this one just checks if the shift has a required skill, then the employee that you assign to it needs to have that required skill. And that's a hard constraint. So if you go back to schedule, you can actually see on the top left, you see a score. And you can actually ask it to explain the score. So you can exactly see why the scheduler or the TimeFold solver has decided to make the schedule the way it is. So for example, I have no hard constraints. I have a positive score of 3,300 because I have 7 employees that got their desired day. So this is kind of a form of explainable AI. It's generating something, but it also explains why certain things were assigned this way. So this is very powerful tech. Now, this was a very simple one. It was only 130 shifts. How about 960 shifts at the same time? 50 employees, and we just get going. So now what's happening is first it makes an initial schedule, and then it starts moving things around, as I said, right? Now, if I go here, you can actually see in the logs. You should be able to see in the logs. Here, for some reason I can't zoom in, but this says 77,000 moves per second. So it's actually moving things around at the speed of 77,000 per second. So it can try a lot of different combinations this way. And then when we get back, it has actually created a feasible schedule for all these shifts. And in case you are not impressed, these are all the shifts, right? And it goes down quite a bit. Imagine doing that by hand. Like as a manual planner, it would drive you insane. So that was a very short demo. So what you do with TimeFold is basically you model your domain in Java classes. So if you're a Java programmer or Kotlin or Python, you can just use your own programming language. You define some constraints. You say, I want it to react like this. And then you run it. And that's how you can create these very complex schedules that are honestly everywhere, and so many people have not automated or optimized for this. We have a few example use cases. So we have vehicle routing, order picking, bed allocation, meeting scheduling. I think there's a cool thing you could build there. Employee scheduling, school timetabling, even conference scheduling, because this is used behind the scenes for the DevOps conferences to make this big schedule. So there are so many use cases that can be built with this. So LLMs can't do this stuff, but there's older forms of AI, old school AI, like the things that Timefold is doing to do these things. So where do we think the future of AI is then? So I really believe that now we are too focused on the Gen AI thing. A lot of people are focusing on Gen AI, and what can Gen AI do for us? And I was talking before, and I actually have a funny twist on that. Maybe we should think what we can do for Gen AI. How can we make it better and expand upon it? And as Timefold, we are in the outer artificial intelligence circle. But even beside that circle, there's a bunch of cool things like workflow integrations that you could do. And I think combining things will be awesome. So for the old school AI, that's Timefold, but other forms of programming as well. We can use LLMs to explain these constraints in a human language. We can support the domain expert when they're making these Java classes and such to help them build it. And we can write code, of course, because that's like the thing that most people are doing now. We can write code. Well, you can write Timefold code that then does this. And there's so much more things that we could be doing. We actually created our own GPT. It was very simple. Go to ChatGPT, you just upload your documentation, and you have your own GPT. It's not fancy, but it really helps users of Timefold or maybe your own products to get on board. So that's how LLMs can support current technologies. But what about LLMs? What can we do for LLMs? Well, we can integrate them. So who was here for the Goose talk? A few people? So in case you don't know, Model Context Protocol is a way that allows tools like Claude or Goose to connect to LLMs with servers that you built yourself. And for example, for Timefold, we did this. This is just Claude. And if you click on a certain button, it shows which tools are available. And we actually made available 2 tools, Automate Schedule and Optimize Demo Data. So this is a proof of concept. It's not live, it's just on my PC. But the LLM is actually capable of calling these tools. So in this way, you can expand LLMs to use all the power of previous forms of AI, previous technologies. And I think this expansion is probably the biggest thing happening now in AI. It's not the LLMs itself, that's like a separate category, but finding cool ways, cool tools to integrate with LLMs and make things possible for the LLM that they normally couldn't do is probably even a bigger, interesting field to work in. So to conclude, because I think I'm almost out of time, we had fun, right? We started with cats and now we're all the way down to LLM, so it's all good. So to conclude, Gen AI is awesome. It is. There's so much stuff we can do with it. I think it's here to stay, and we can do just amazing things with it. But it can't do everything, and we need to keep this sharp because so many people are now looking at ChatGPT or Claude or LLMs, and they think, I'm just going to let it do everything, and then they get frustrated because it can't do certain things. So whenever that happens, try to investigate why can't an LLM do this, and then maybe with MCP and such, you can find a way to make it possible for the LLM, to give it tools so it can do these complex things. So, especially since we're now so super focused on Gen AI, it might be a good idea to look at other forms of AI and machine learning, because there's a lot of value in there. And I was very excited that I could join Timefold after being a fanboy for the product for quite a while, because I believe that that's an amazing technology that will enable a lot of people to do their job a lot better. Like if you don't have to spend an hour or 2 every day to create a schedule for your employees, if you can make a timetable for the school in the neighborhood, if you can insert other use case, there's so much more time left. So as part of Timefold, our mission is kind of to free the world from wasteful scheduling, because we think a lot of time and money and effort is being wasted. And I would like to invite you to also give it a try. If you don't think this is for you, all good. I think it's the most awesome thing I've ever worked on. It will help you create schedules. We actually have a quick start page that has a few quick starts for different use cases that you can just pull from Git, run. Actually, the employee shift scheduling use case I showed you is just a quick start, so it's available to use. And that's kind of where we're going towards. So if you take anything away from today, you learned a lot about AI if you stayed in this track. Use it, but don't just look at what AI can do for you, but also what you can do for the LLMs. And that's the end of the talk. I hope you had a nice conference. See you next time.